Alright, in this video, I'm going to cover how to work Chapter 10, which is dependent T, using the Nolan and Heinzen 6-step procedure. And so we're going to work through the examples that we did in class and talk about how I got the numbers I did. Okay. So we're examining student satisfaction. So we got a new rec facility with a super fancy pool. And we want to compare that to previous rec facility, which was kind of sad. And we want to know if students are more satisfied with our new facilities. I'm going to use P less than 0.01. So I got the data here for new and old facilities, and I cut and pasted those into Excel and saved it as a CSV, and that's what we're going to load into R. Okay. Remembering that each person gets their own line, and these are the same person asked about old and then asked about new. So first assumption that the DV is scale. And here it's an interval scale because we asked them on like a 1 to 5 scale. So yes, it's at least scale. Then the question is random selection. Now if I'm asking them about the rec centers at school, I would have access to the entire population. So I could randomly email, I suppose. But let's say I didn't do that. I could randomly assign which question went first. So even if I didn't randomly select, I could randomly assign the order that they got. So I could counterbalance. Some people get the question about old first and some people get the question about new first. And is it normal? Okay, the assumption is that it's normal, or the question is that it's normal. So don't just write any less than 30. You say not sure because we can't assume it because n is less than 30. So the assumption isn't that the sample size is 30. Remember, the assumption is it normal, which we can be assured of if the sample size is 30. Okay. So for step 2 really here, because step 1 is the assumptions, so we can just kind of delete that out. We can do the research, and this is where it gets tricky with dependent T and this style of thinking about hypothesis testing. Because remember, the population is where there's no difference, or that mu is 0. So I have to come up with a research hypothesis where we expect scores to get better than 0. So we're expecting, word will play along here, a greater than 0 score. And I just always look at the first row of data to figure this out. So if I subtract old minus new, the score would be -2 for this first person. And -2 here implies the score is going up 2 points from 2 to 4. And that doesn't make a whole lot of sense. So I'm going to do new minus old. And the difference there will be 2 points positive because new is better than old. So I'm going to do the difference between new minus old in that order so that I know that new, if the scores are positive, new is better. Okay. And we're going to copy all that. Here we would say less than or equal to. So be sure you're getting the hang of these opposite hypotheses. So if your hypothesis is that it's greater than, then null has to be that it's less than or equal to. So the first thing we're going to figure out is our mean difference score. We're going to take our standard deviation of the difference scores, not to be confused with S difference in independent T chapter. If you aren't there yet, you will be soon. But this is of the difference scores and not the differences between means. That semantically I know is very, very similar. But what we're talking about here is the difference score of like time 1 minus time 2 or something to that effect versus group 1 minus group 2. Okay. We're going to assume mu is 0. And I think that's it. We also have n. So n being the number of pairs and not the number of physical scores. So I know I have 1, 2, 3, 4, 5, 6, 7 participants and 14 scores, but it's still only 7 participants. Okay. So let's go over to Studio. I'm going to import that data. So import data set from CSV. I'm going to find it on my computer here. This is data 1. and click import. Now the script that I have on Blackboard is going to be a little different than this, simply because the new version of the import function does not like to import with underscores, which we saw in class. So I've got my data imported, and I see that each person gets their own row. And I'm going to smack the dog because he's making a lot of noise. 1 second. Quit. All right. The joys of recording at home. So each person gets their own row, and I've got 7 rows here. And then what we're going to do is figure out that mean difference score. So I'm going to subtract this in the same order. So I'm going to create a difference score where I'm going to take my chapter 10 data here and take new minus my chapter 10 data here. Oops. Spelling matters. Old. So by doing new minus old, I know that this, if it's positive, the scores have gone up. So I've done it in the same order as I have over here. Because the sample is really about the difference between these two scores, not new versus old. I mean, it is new versus old, but the old is not the population. The population is the difference score between the two. Okay. Things are just crashing everywhere. So let's calculate that mean of our difference score. That's 0.86. Our standard deviation of that difference score is SD of the difference. And that's 1.07. So the change in our sort of happiness with the rec facilities is less than a point, and it varies about a point on each side. Okay. Now my standard error of the difference score, remember this is the Oprah, so everybody gets a little bit, is that 1.07 divided by the square root of n. But I'm going to do that fancy over here. So I'm going to take my standard deviation of the difference, and then I'm going to divide by the length, square root first. So SQRT of the length of my difference score. Remember, the length function tells me how many scores there are, so there's 7. Square root function takes the square root of 7, which is a little less than 3. Standard deviation divided by the square root of n is 0.40. I don't know why that was so hard to say. 0.40 here. So these are all the numbers I need. Because remember, the calculation for t is going to be the mean difference over standard error. The calculation for Cohen's d is the mean difference over standard deviation. And we need this bad boy for step 4, and we're assuming mu is 0. Alright, so we're going to use p less than 0.01, because that's what it's suggested here. More satisfied is a one-tailed greater than test. So we're going to use QT, 0.01, divided by 1, basically, for one-tailed test. Degrees of freedom goes here. So degrees of freedom, remember, is n minus 1. So that makes it 7 minus 1 in this case, which is 6. Do lower dot tail, and I'm going to go false because I have a greater than test. Plop that over here. Run that. So I got 3.14. So that's kind of a difficult score to get to. It's 3 standard errors away from the mean. Step 5, we're going to calculate t. We can do this one of 2 ways. We can do t.test. And remember, whoever you put first here needs to be first here, because it's going to do the subtraction in the same order. So new, old, paired equals true, or this is going to give you the wrong test. And we could do alternative equals greater, and conf dot level equals 0.99 in this instance. So I'm going to plop this in here, and then we're going to look at what happened. So I got t equals 2.12, which is the main goal here. But that allows me to check my degrees of freedom, which is 6. Okay. It gave me a one-tailed confidence interval, which is not really what I want, but I do see that my mean difference score is correct too. It tells me the differences in means is greater than 0, so that actually matches my research hypothesis. Let's first talk about whether or not we're going to reject, and then we'll show you the other way to get t, ci's, and effect size. So do I reject? My t found is 2.12. My t critical is 3.14. I already didn't make it by almost like a whole point. So I'm definitely not going to reject the null. So I'm going to fail to reject. I'm going to fail to learn how to spell. There we go. So, all right. Confidence intervals. I have nothing down here. See all this blankness? So I'm going to run my f size script. And then I'll get a bunch of these different functions. Over here in calculate R, we want to do dependent t differences. Be sure you do the differences one so it matches my answers, but also it matches the scoring online. There are 2 different ways to do dependent t. We're doing differences in class. So our mean difference here was this number, 0.86. Our standard deviation of the different scores was 1.07. I'm just cutting and pasting here. N was 7. Alpha here is 0.01, so we get the right confidence interval, and k equals 2. And I can hit enter in the middle here, so I have a little bit more space to see. I'm gonna run that. I'm gonna ignore this warning. I can triple check what I did. So my mean difference, my standard error is 0.40. Here's my confidence interval of the mean difference, which includes 0, so I wouldn't reject the null. So remember, there's always a dash here, so it's negative 0.64 to positive 0.236. So that includes 0, so I wouldn't reject the null in a two-tailed test either. My t, I got 6 degrees of freedom. That matches 2.12. That matches what I got up here. Here's my effect size. And I would say this is a large effect. So even though we didn't find a significant difference, it seems to be a large change in how much they like the rec facilities. And so we should be pretty happy. Hopefully you guys are happy too because you're still paying for it. So that would be one example. Let's look at how we want to work the second example. So we're trying to determine if we should change our disposal fees. So if we increase the fee, are people going to reduce waste? Okay. So the whole point is for the waste to go down because that would relieve, still haven't fixed it, trash truck drivers. Okay. So should they increase the fee? So should we increase the fee because it'll reduce waste? So this is actually a one-tailed less than test. So here are my scores. So first assumption, dV is scale. Yes, we could have a ratio scale, no bags of trash. Can I randomly select? Yeah, I own the business, the trash business, where I could randomly pick which house to monitor after increasing the fee. However, in this case, could I randomly assign? No, because I can't randomly assign before and after. I can't change the order of that. Is it normal? Well, N is less than 30, so don't know. So I don't know if my bags of trash scores here are normal. For step 1 here, we're going to do a significant reduction in waste. If I take after minus before, so 5 to 8 here, that's actually going up 3 points. So if I did 5 minus 8, that would be negative 3. And negative 3 would imply that the scores are going down. But they're not. They're going up 3 points. So I'm going to do after minus before, and that's going to make it clear for this house that the fee didn't matter. They increased their trash bags. But 4 minus 6 is a negative 2, and that is going down. So we're going to do the difference in after minus before is less than 0. Okay, because we're assuming no change or no difference or mu m equals 0, however you want to think about it. And we want that to be less than 0 because we want a reduction in waste. So that means for our null hypothesis, we really don't want it to go up or be equal to. Step 3 here, we're going to do the mean difference score. Oops, try again. The standard deviation of the difference scores. Right, not to be confused with differences in groups. The standard error of the difference score. Try again. And n equals something, and mu m is 0. So let's do the same almost exact thing we did last time. I am going to import that data. Import data set from CSV. Find it here, chapter 10 data 2. Just import that. Okay. I'm going to do the same thing. Difference equals my chapter 10 data 2 after, minus, me and my bad typing, before. Okay, so now I have a new difference score where the first person went up 3 bags of trash and the second person went down 2 bags of trash. So 8 minus 5, 4 minus 6. I'm going to calculate that mean of my difference score. It's negative 1.25. The standard deviation of the difference score is 2.25. So we're going down 1.25 bags of trash, but there's a lot of variation there. It's 2 bags of trash variation. That implies that some people are actually going up. Ooh, which is no good. We're going to take our standard deviation of the difference score, divide by the square root of the length of the difference. Okay. And that gives me the square root of n. I get 0.80. And how many people do I have? Well, I can look here at my difference scores. There's 8 different scores. I can run the length of my difference score, which is 8. I can see here that I have 8 observations. A couple ways you can figure out they're 8. You can count them. So n equals 8 here. So for step 4, I'm going to use p less than 0.05. So you don't have to write this. I just am writing it so that you know why I'm doing what I'm doing. I'm doing a less than one-tailed test. So we're going to use QT. 0.05 divided by 1 for one tail. I'm going to come up with degrees of freedom here, which is n minus 1. So df is 8 minus 1, which is 7. 7 here. Lower tail equals true, because I want a less than test. Oh, sorry, 0.05. I missed a decimal here. There we go. Negative 0.89, 1.89. Sneaky decimal, there we go. So that's negative 1.89. Let's get t. So again, 2 ways to do this. So we're going to do t.test. Write this up here. Different steps. I'm going to do chapter 10, data 2. We're going to do after first, so the subtraction's in the right order. Before second. Paired equals true. Absolutely do not forget that, or you will totally get the wrong answer. The math is really pretty different. Alternative here is less. And conf dot levels 0.95. I've got my t here. Stick this on a new page. So I got 7 degrees of freedom. I did that part right. Here's my actual T. My one-tailed confidence interval, but I want the two-tailed one. And the mean of the different scores. So I got my mean and my DF right. My T found was negative 1.57. My T critical is 1.89, so I just barely missed it, but I'm going to fail to reject. I'm recording several videos tonight, and none of them are reject, which is sad. So, but let's see if that's a significant reduction in, it's not significant statistically, mathematically significant, but let's see if it's a practical significance. So let's look at that effect size and that confidence interval. So I'm going to cut and paste this dependent T differences thing. Now, I have not closed R, because you've been watching me do this, so I still have them all down here. These have to be open or this won't run. My mean of my different scores was negative 1.25. My standard deviation of the different score was 2.25. In here was 8. Alpha for type 1 error is 0.05. We're going to run that. Confirmation that I've done a couple things right. So my standard error is 0.8. That looks good. Here's my confidence interval, which includes 0, which is, I wouldn't reject the null even if it was a two-tailed test. Got the same T value. Here's my effect size, so it's a medium effect. Which implies, while it's not statistically different, maybe it's practically very important. So it's helping out their truck drivers and it's reducing waste, which is always a good thing. And so those examples are how to do dependent T using R and the 6-step procedure from the Nolan and Heinzen books.